Okay, 2.6 notes over constant, constant multiple, and sum and difference. So continuing off of learning everything about derivatives and the power rule, we're going to learn a few more, and that is going to be mainly the most important, the sum and difference. So constant, think of constant as anything like a number. So the derivative of any number is just 0. Constant multiple, this is the same as saying like a single variable. So this is like saying 5x. Well, the derivative of a single variable is just going to be the coefficient in the front. So in this example would be 5. Okay. In the general sense, it would just be c d dx. And then sum of difference means that no matter if we have two functions, if they're adding or subtracting, we'll take the derivatives of them separately. So the derivative of u plus v or u minus v is just going to be u prime plus or minus v prime. So let's look at an example here. So in order to find this derivative, this would be y prime is equal to 4x. And then before I do this, I would change this to be negative 5x to the negative 1. Because it's a lot easier to take the derivative of this than it is of the x where it's in the denominator. So when I take the derivative, I'm going to do negative 1 times negative 5, which is positive 5, x to the negative 2 power, because remember I subtract 1 from the exponents. And then my plus 6, since it's constant, will go away. The only thing I have left to do is make sure I get the negative exponent away. So then y prime would be equal to 4x plus 5 over x squared. The next example, we can rewrite y as 8 times x to the 1/2 power minus 1/3 x to the 6th power. Notice that this wasn't a variable, so I didn't write 3 to the negative 1. I just brought it off to the side as a fraction. Okay, and then plus 2 pi to the 5th, but when we're taking the derivative, realize that this is just a number. This is just a number. So if I take the derivative, y prime is equal to 4x to the negative 1/2 minus 2x to the 5th power, and the number 2 pi to the 5th is going to go away, which means I would simplify this to 4 over the square root of x minus 2x to the 5th power. Now let's talk about horizontal tangent lines. It says, when does a function have a horizontal tangent line? Well, we know that the slope of a horizontal tangent line is 0. So in order to find a function that has a horizontal tangent line, we have to set the derivative equal to 0. So for number 3, it's saying find all the x values of any horizontal tangent lines of the following function. Well, we know that we need to set the derivative equal to 0. So first I need to find the derivative. So f prime of x is equal to 8x plus 7. Set this equal to 0. I have a is equal to negative 7, which means x is equal to negative 7 over 8. So at the x value, negative 7/8, I will have a horizontal tangent line. Okay. We also know that we have horizontal tangent lines when our graph is starting to change direction. So notice how it's increasing, then it's decreasing. It's decreasing, then it's increasing. At these areas here is going to be the horizontal tangent lines. Then we have normal lines. A normal line goes through the same point the tangent line does, but it's perpendicular to the tangent line. So it says find the equation of the normal line given f of x at x equals 3. Well, first we have to find the slope, which is the derivative of f. So f prime of x is equal to 3x squared minus 8x plus 1. I'm going to plug in 3, so f prime of 3 is equal to 3 times 3 squared minus 8 times 3 plus 1. This is equal to 3 times 9 minus 24 plus 1, which would simplify to 27 minus 24 plus 1, which is 4. So this means 4 is going to be our slope of our tangent line. But the slope of the normal line is going to be perpendicular. Remember, a perpendicular slope means opposite reciprocal. Or in other words, we change the sign and flip the fraction. So that means that the slope for the normal line is going to equal to negative 1/4, the opposite reciprocal. So if I'm able to find that perpendicular slope, then I can write my normal line, which is going to be y norm plus 3 is equal to negative 1/4 x minus 3. That would be my answer. Okay. I could show that visually off to the side. So let's say I also found my tangent line. So y tangent plus 3 is equal to 4x minus 3. My tangent line and my normal line is going to go through 3 comma, let's see, 3 comma negative 3. And that's me plugging in 3 into the original function. Okay. So I know that this is my tangent line, approximately. And then since my other line is perpendicular, I know it's going to cross about right here, so it's going to go like this. So green is my normal, red is my tangent line. Okay, now we're going to talk about differentiability with piecewise functions. So number 5 says, is the function f of x differentiable at x equals negative 1? Well, in order to determine if it's differentiable, we have to first check if it's continuous. And remember, we know that it's continuous if f of c is equal to the limit as x approaches c of f of c. So first we have to see if the limit exists. So I'm going to plug in both negative 1 into both of the piecewise functions here and see if they are equal to each other. So I have 5 times negative 1 squared plus 3 times negative 1 plus 2 is equal to negative 7 times negative 1 minus 3. Okay. When I do that, I notice I get, let's see, that's positive, so that's 5. 5 minus 3 is 2. 2 plus 2 is 4. And then negative 7, negative 1, that's positive 7 minus 3, 4. So they both get 4. Okay. So that proves that it is continuous. Okay. Now I have to prove if it is differentiable. So in order for it to be differentiable, then the limit of the derivative has to exist. So that means the limit as x approaches negative 1 of f prime of x has to exist, which means I take the derivative of both of them. So 10x plus 3 is equal to negative 7 when I plug in negative 1. Okay, so 10 times negative 1 plus 3 is equal to negative 7. That's negative 10 plus 3, which is negative 7, which means yes, it is differentiable. Okay. Number 6 says, what values of a and b would make the function f of x differentiable at 3? So first we're checking, well, is it continuous at x equals 3? So we have to check that. So in order for it to be continuous, then we know that they would be equal to each other. So x squared minus ax plus 2 is equal to x plus b. X is 3, so 3 squared minus 3a plus 2 is equal to 3 plus b. So I have 9, 10, 11. So I have 11 minus 3a is equal to 3 plus b. Let's see. Okay. The next thing I'm going to check is that I know that if these have to be equal to each other, then the derivatives have to be equal to each other. So now we're checking differentiable. So take the derivative of each one first. So that's 2x minus a is equal to 1. Plug in 3 for both. So that's 2 times 3 minus a equals 1. 6 minus a equals 1, which means a equals 5. Now I can go back and check b. Well, 11 minus 3a equals 3 plus b, which means 11 minus 3 times 5 is equal to 3 plus b. 11 minus 15 equals 3 plus b. Negative 4 equals 3 plus b, which means b is equal to negative 7, and then we found our answers for both.